All right, here we go. Getting into the graphing portion. There's been a lot prior up to here, so I'm going to take it fairly slow. First thing is that we see our function to be g of x equals 4 sine x. Now, if we were to just look at the plain old y equals sine x, and we, put in that a and the b, where do we see this 4 taking place? Is this 4 an A or a B? Hopefully you're looking at it and you're saying that's A. So A is 4, because it's the absolute value, but that's already positive. So this right here is a vertical stretch of 4. Before you even try to graph, what we're going to do is we're going to pull back out that table between 0 and 2 pi, with pi in the middle, pi over 2, and then 3 pi over 2. And this is for the parent graph of just y equals sine x. 0, 1, 0, negative 1, 0. What we are going to do is we are now going to take this knowledge that A is a vertical stretch and it is affecting our output. We are stretching our y values. And we're going to go ahead and take our table, and it's going to be 4 times each of those. So x and y. Our x values have not changed. If you see, the x values are only changed when you have a variable that is b. Now, b is 1 in this case. Let me do it in a different color. B is 1 because we don't see anything. Therefore, the period is 2 pi over 1, which is just 2 pi. And that's why we are still just going from 0 to 2 pi. Pi in the middle, pi over 2, and then 3 pi over 2. Now, A affects the y values. It affects that output, that range, all of that. It's that stretch. So it's going to lift our graph up and pull our graph down more. What we are going to do is we're going to take 4 and multiply it to this sine function. Because if you look at it, this right here is sine x times 4. So all our values are going to be multiplied by 4, which for 3 of them, it's still 0 because 0 times anything is 0. And then the 1 turns to a 4, and the negative 1 turns to a negative 4. And now, you guys have your 5 points for your first graph. So let me go ahead and shrink this down a little bit. I'll pull in this graph. Now, typically when you do sine and cosine, you guys you will need to be using graph paper. It's very important to use graph paper because it will allow you to label and represent these pieces better. So what I'm going to do is I'm going to count out some squares. Every 2 squares is going to be a pi over 2. Make sure that you are, trying to keep your graph organized and labeled, and then, it keeps going on. 5 pi over 2, 3 pi, I just labeled it, and then this is a negative pi over 2, just to give you guys the view of these pieces. Now, for my y values, sometimes you may want to scale your axes. I'm not going to. 1, 2, 3, 4. 1, 2, 3, 4. Now, if we were to look at full-on accuracy, pi is about 3.14, and that's 4 up. So they're not 100% perfect in the world of correctness in numbers, but I have it labeled so we know where it's going and what it's representing. So I'm going to go ahead and graph these points. My first one is 0, 0. Then I'm at pi over 2, 4. Pi, 0. 3 pi over 2, negative 4, and I didn't even label that as a negative. That's a negative 4. And then 2 pi, 0. Now, I could stop here, but it's going to follow the same pattern, and it's going to go in the opposite direction with the same pattern. So honestly, I'm just going to label all those points just so you guys can visualize it. Now I'm going to draw the line between them. It needs to be curved. It's not an absolute value. So there needs to be curving going on at those maxes and mins, maximum minimums. And from here now you can go ahead and see that this is our graph. It looks cyclical, and honestly, if we were to continue it, it would keep going and going and going on forever. However, we are only going to graph 1 or 2 periods at a time. If it's 2 periods, it will be labeled that way. But for now, that is it. And there's going to be 3 more problems, 3 more graphs that you guys have before you go into your homework, because I want to make sure you are prepared.